So let's just talk about the cell sort algorithm. So the cell sort is the optimized version of the insertion sort. Here it allows the exchange of 4 elements. So that means we can sort the elements at a specific gap and then gradually reduce the gap. So the question is why we should need this cell sort, because we already have insertion sort. So in case of insertion sort, we chose one element, we compare this with all the previous element, and then we shift them to the right so that we can insert this at the correct position. Now the disadvantage of this approach is that if we have one smaller element at the end of this array, so in that case we have to shift all the previous element to the right so that we can put that smaller element at the beginning of the array. Now because of this we have to do a lot of comparison and shifting. Because of this it takes a lot of time. So in that scenario, insertion sort has the complexity of O(n) square. Now to optimize this we use the cell sort, which is optimized version of the insertion sort. So in the cell sort algorithm, first of all we chose one gap sequence. Like an example, we can choose n by 2. N is the size of the array by 2. Then we can half that. So next we're gonna have n by 4. Then again we're gonna have this n by 8 and so on. So instead of comparing all the elements one after another, we can choose one gap sequence and we can exchange those elements. So the cell sort is basically one insertion sort but with a gap. Now with this approach, the advantage is that the smaller elements from the end of the list will go to the front of the list pretty fast. So because of this, in the final pass our array will be sorted or partially sorted. So we have to do fewer shifts in the final pass, so which hugely improves the time complexity. So it has the best case complexity of O(n) log n, and in average case if we choose the gap correctly, then the complexity can be order of n raised to the power 1.5, and in worst case we have the complexity of O(n) square. So let's just see how we can sort these elements using the cell sort. So the first step is to choose the gap. So because here we have 7 items, so the gap will be 7 by 2. So we have to float the result, so the gap will be 3. So that means we're gonna compare the elements with the gap 3. So the second step is to perform the insertion sort for the elements separated by the gap. So that means we're gonna compare these elements and we're gonna perform the insertion sort. So because 5 is lesser than 6, so that means we do not need to swap them. So we're gonna continue with the next pair of elements. So we're gonna compare 2 and 3. So because 2 is less than 3, so again no swap needed. So we're gonna continue with the next pair of elements. So now we're gonna compare 8 and 1. So because 8 is greater than 1, so we need to swap them. So 1 and 8 will be swapped. So because we have a swap, so we have to compare this with the previous element with the same gap. So because there is no previous element, so the value 1 will be placed right here. And next we're gonna compare 6 and 4. So because 6 is greater than 4, so we need to swap them. So that means the value 6 will be shifted to the right. So because we have a swap, so we're gonna look backward with the same gap. So with the same gap, if we look backward, you can see we have the element 5. So now we have to compare 5 and 4. So because 5 is greater than 4, so again 5 will be shifted to the right and 4 will be placed at this position. So we are done with this pass 1 where the gap was 3. So the next step is to reduce the gap and repeat the same process. So let's now go for the pass 2. So after the pass 1 we have the elements 4 2 1 5 3 8 6. So in the pass 2 the gap will be reduced by half, so the new gap will be 1. So that means we're gonna compare the elements with the gap 1. So that means it will work the same way as the insertion sort. So that means we're gonna compare 4 and 2. So because 4 is greater than 2, so we're gonna swap them. So 2 and 4 will be swapped. And next we're gonna compare 4 and 1 because 4 is greater than 1, so they will be swapped. So the number 4 will be shifted to the right. And because we have a swap, so we have to compare with the previous element with the same gap. So previously we have 2, so we have to compare these two elements. So because 2 is greater than 1, so again we have to perform the swap. So that means 1 and 2 will be swapped and 1 will be placed at the first position. And next we are gonna compare the elements 4 and 5. So because 4 is less than 5, so we do not need to perform any swapping. So we're gonna continue with the next two pair. So because 5 is greater than 3, so we need to swap them. So 5 will be shifted to the right. Because we have a swap, so we're gonna compare with the previous element 4. So because 4 is greater than 3, so we have to shift 4 to the right position. And again we're gonna compare with the previous element. So because 2 is less than 3, so 3 will be inserted right here. Again we're gonna perform the comparison for the next two elements. Now we're gonna compare 5 and 8. So because 5 is less than 8, so no need to perform any swapping. We're gonna continue with the next two pair. So now we're gonna compare 8 and 6. So because 8 is greater than 6, so that means we need to swap them. So 8 will be shifted to the right. So because we have the swap, so we're gonna compare with the previous element with the same gap. That means we're gonna compare with the element 5. So because 5 is less than 6, so we do not need to perform any swapping. That means we can insert our 6 at this position. So that means we are done with the pass 2 also. So after the end of this pass with the gap 1, you can see our array is now sorted. So this is the way we can perform the cell sort, which is the optimized version of the insertion sort. Here all the major shifting already done in the pass 1. So in the final pass we have less number of shifting, which greatly improved the time complexity. So hope you understand about the working of the cell sort. See you in the next one. Take care.